would you like this one? This one.
I haven't seen that yet. Maybe, is there any way you can tell when it's recording? I guess it looks.
Yeah, the red one is like really cool.
So,
Oh, can you say something to the mic?
Yes.
Because I see it.
check. Hello.
Okay,
hello.
yeah, I can see that. It's
Okay.
up and down.
So you have to some sort of indicator.
Have a nice day. Bye.
All right, so on Friday we started a new Keynesian model, right? The dynamic stochastic general equilibrium version, right, of or insight into what or equivalent companion to the ISLM model. So the modern quantitative equivalent of the ISLM model. We started looking at the households. I'm going to briefly just go through that again. And then we're going to go to the other half of the interesting group of people, and that's the firms. Again, so the idea here, why do we want to learn this sort of model? Why are we interested in DSG models? Because it's on the exam, right? No. Well, maybe that's part of it too, but the most important reason, hopefully you can start to sense, is that from ISLM, we, on the one hand, we're able to make qualitative predictions. If interest rates go down, then output is going to go up, but by how much and when? Right? We were a little less confident in that. And we also saw there's a number of different things that can adjust that might reduce the effect of a policy change, like the nominal interest rate change or a government expenditure increase. Right? What happens on the investment market with the interest rate was the first standard way to think about this with crowding out. We also thought about, well, what if prices adjust and adjust completely, then maybe there's no multiplier effect at all. But how do prices adjust? There's no explanation for that in ISLM, it just assumes they're fixed. And you have to kind of guess. There's some additions that you might have looked at in an introductory course at the master's level or in your bachelor's, like an ASAD model. So the AD would be ISLM, and we could add on top of that some description of how prices adjust. This AS curve is simply the Phillips curve, and our price, yes, it's simply the Phillips curve, in other words. And we're going to replace an arbitrary ad hoc Phillips curve with a micro-founded version, just like we have a micro-founded version of households' decision-making process that we saw on Friday, gave us a consumption Euler equation, just like we saw in the household model of consumption savings. So we have this idea that we can see that households are going to adapt their decision rules based on the environment they find themselves in. And this adaptation is going to be such that they maximize their expected discounted sum of lifetime utility. Right. Important here, again, remember from Friday the way this is written, we start off at the some beginning of time perspective, so t equals 0. So when we write down our optimization problem, it's conditional on information at time 0. Right? The idea is, okay, at the beginning of time, we come up with a plan for consumption today. Because determining consumption today means also determining how much we're going to save today, right? It's, the two are inversely related, but our decision on how much to save today, of course, depends on how much we want to consume tomorrow. It's the only reason why we're saving. Well, how much do we want to consume tomorrow? We have to figure out how much we're going to save tomorrow, which means we have to figure out how much we're going to consume the day after tomorrow. And so we quickly discovered that our contingency plan today requires us to come up with a plan for all future consumption, a plan for all of our future actions. Right, so at period 0, right, we're coming up with a plan for our future. Right? it's important that I emphasize this for me because, on the one hand, right, we're thinking ahead, but on the other hand, every period we redo the same calculations. Things change and we come up with new plans. So when I wrote this problem up on the board and we worked through this last Friday, we wrote out the perhaps more complicated s equals 0. We do t plus s, t plus s, t plus s. Right, this would be the way of writing this where we re-optimize at every period t. Right? And we saw that the only sort of tricky part of this was when we got to the first order condition. With respect to the bond holdings. And then we saw that we had to write out these expectations explicitly. And these expectations were then conditional on time t. If you write out the first order conditions of this problem, and you take the derivative with respect to CT, you're going to see it's going to be the expectation at period 0. Right, so how are these two? Last week, T perspective, think of this as T plus S in the optimization problem. And we got, say, we got from lecture slide. If we start directly with this problem, we're going to get then equals B0, U of C0, N0, and you'll notice that then we have to start the optimization at the period 0. So we get, we are going to get first order conditions. So compare this from last Friday. We will get, say, U C of 0 equal times Q0 equals beta E0 UC1 times P0 over P1. Or I think we wrote this. From DL, DQ, B0, and could take the derivative with respect to dt and ct from the time 0 perspective. All right, and this would give us 0 equals beta t E0 U CCT NT minus lambda t pt, and 0 equals beta t E0 lambda t minus beta plus 1 E0 QT right, I mean, we can maybe cancel out this beta t, so we get something that looks, so 0 equals E0 E prime or U of C CT NT minus E0 lambda t pt. And here, same thing, so it's equals E0, get rid of this beta to the power of t. Qt minus beta right, and then so 1, we can't get any further, and 2, this isn't quite the same as what we had on Friday. So right, why can't we reduce this any further? Right, to get to this expression, what we would have to do, or if you look at the time 0 perspective, is we solve for lambda 0 and then plug it into here. We can't solve for lambda 0 in this first equation. Why not? Because we have the expectation of a product. You know? Jensen's inequality, right? Think of correlation covariance. We saw the same sort of expression we're looking at the asset pricing. If our marginal utility from nominal wealth is correlating with the price level, right, then those terms are going to be the covariance term. Do you think that's going to happen? Do you think the nominal value or the value to you of having a dong depends on how much, or is related to, is correlated with how much you can buy with a dong? Well, yeah, that's kind of probably one of the most important parts. You know? So the value of money related to the price level, those two things are going to be related, right? So we should certainly expect there to be a correlation, so we should certainly expect this to not equal the products of the products of their products of their expectations. Right, so we can't solve for this term to point, oh, we've also got, and we've got a correlation there. This is going to be very difficult to solve for if we take statistics seriously, which is what we want to do. Right? And this is sort of, in some sense, makes sense, right? When you think about how much to invest, how much to save, one of the key things that's going to be, right, on the one hand, you want to figure out, you might form expectations today about how hungry you're going to be in the future. But when determining how you're going to satisfy your hunger in the future, by how many dong you're saving today, right, that's going to be intricately related to how much you think the dong is going to be related to the future. All right, so of course, this whole savings problem is, on the one hand, I want to save for the future, but if I think there's going to be a lot of inflation, then maybe saving in bonds isn't going to be the right way to go. Talking about money. We're just going to do a brief discussion about money, and then we're going to come back here. So, right, what is money? So this is 20 euros. Why is it money? I mean, it's a pretty piece of paper. I don't know, some nice color, some pictures of architecture they do in Europe, right? Similar here, right? This is also. This is just as pretty, just as colorful, right? Here we have, right, 20,000 dong color. So there's something. Maybe that's why it's valuable, right? Because it's pretty. You know? Right, this is $100 in America. I don't know. We're not as colorful. Benjamin Franklin. I don't know. Maybe that's pretty. Maybe not, but $100 is still, right, is worth something. How about this one, right? This one is, I think, it's just as pretty, right? Maybe prettier, right? Unfortunately, I can't spend this. Why is this worth nothing?
Because people don't believe
They haven't known about you.
They don't know about this. There's something about trust in this, right? Yeah. So the important thing about money is trust. For whatever reason, we trust this old guy, but not this old guy, right? If you look historically, so it's the same guy. It's Benjamin Franklin. It's a $100 bill. This is from 1920. Right? And an old currency in America. It was worth something real, people claim. Why? The dollar was defined as a fixed amount of gold. So you could take that bill and say, I don't trust the US government anymore. Here's your piece of paper, give me my gold. Right? But, okay, but gold is definitely worth something, right? Well, I don't know. If you're hungry, can you eat gold? No. You have to find someone else to give you food in exchange for gold. It's the same way money works. Why would someone else give you food in exchange for gold? Because they trust, they're convinced, they're sure that they can take that gold and give it to someone else for whatever they want. Right? So, in some essence, there's really, gold is based on trust in its valuation just as much as money, right? And why is that also an important thing to think about? There are many times, many crisis situations where maybe gold is more valuable and we're scared about the value of money. In other situations, gold is worth nothing at all. If you think of a famine, right? If there's a natural catastrophe and people don't have food, right? gold is maybe not worth anything. What you need then is maybe rice would be the biggest commodity. Yeah? As we gave you the story, like, this is a passed around, some money from America, right? This is an example of it's a $0.50, so it's the same as the same dollar. The dollar doesn't change its definition. This is from 1796, right? So I could technically, I should pay taxes as an American, even though I've been living in Germany for 22 years. I still have to file taxes in America. I could give the government a coin from a couple hundred years ago to pay my taxes. This is still valid currency, so it's still worth 50 cents. But it's made of silver. Silver is maybe worth more. So $6.50 worth of silver. This is a very old coin. Some collectors think it's really valuable. It might be worth $10,000, or maybe $150,000. So what is it worth? We have 3 different options based on 3 different valuations, right? It's sometimes harder to say. Here's another example, right? It's a coin, it's a little bit older. Queen Elizabeth isn't around anymore, right? It's from Canada, and it says $1 million, $1 million Canadian dollars. That's a valuable coin. All right, so 1 million Canadian dollars is probably, I think, maybe 600,000 US dollars. But it also has another value, just like the silver coin, the silver value. This is made of gold. It's a coin made of 100 kilograms of gold. This was a huge coin. This was in a museum in Berlin. People broke into the museum and rolled the coin out of the museum and stole it. It's really sad. So this was, the value of this in terms of collector's value. There aren't a whole lot of 100 kilogram gold coins, so who knows what it's worth. And they're pretty sure that the criminals, the thieves, stole it, melted the gold down. They didn't want to spend it in a store in Canada. They'd be caught. They weren't collectors, so they probably sold it for the gold town. Right? And as I said, so there are many situations in time when many other things have functioned as currency. Today, right, what do you use for currency? I see you, typing something on your cell phone and showing the person in the cash register your cell phone. That's working as money too. We have lots of electronic ways. Historically, grain, I give you a good example, even today, in a crisis situation, food stuff that's has a good shelf life. So maybe in modern times now, if we had a disaster, huge disaster, COVID we received, I don't know what was it like here, and it's a good question for me. In the grocery stores in Vietnam, did you have any shortages during COVID where you couldn't find something? So in Germany, when we had lockdowns, Germans got scared and they wanted to buy stuff just in case. Right? So food like rice or wheat grain historically would be good because you don't know what's going to happen and that will last a long time and you can always eat it. Right? You can cook it later. And in Germany, the supermarkets, they ran out of rice, noodles, and toilet paper. Right? So, right? So people are still people. Historically, cigarettes. So especially after the Second World War in Germany, for example, cigarettes were used as a currency. American cigarettes were more valuable for whatever reason. And in American prisons today, even if you don't smoke, cigarettes are also used as a sort of currency between prisoners. Historically, some cultures, right, we have pretty banknotes today, these use pretty shells. All right, and now you get to the idea of the value of money. So this is another piece of currency, just as pretty as the dollar, just as pretty as the euro, just as pretty as the dong, right? $1, it's from Zimbabwe, so some national monument, or it's a natural monument, so these rocks stacked on top of each other. Harare, that's the capital in 2007. And 1 year later, right, it's the same natural monument, the same 3 stones stacked on each other. It's Harare 2008, and it's now $100 trillion. Right? This is a hyperinflation from $1 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 zeros within a year. You know? When we think about the price level and the value of another unit of currency, those two things are obviously going to be correlated. You know? One more of these, $1 a year later, right, was worth nothing. Or 100 trillionth of what it was before. Right? So, and so, you know, hyperinflation is not something like, you know, we had a period of high inflation after the COVID in Germany and EU and the United States, paid 10%. You know, inflation is not like, you know, hyperinflation is not 10% inflation or 20% inflation. Hyperinflation, we're talking about enormous. So month over month of 50%, which means over the course of a year, that would translate to 2,000%. Or, right, they had a monthly inflation rate of 100%. That means, right, prices doubled every month. Yeah? And we get to the height of the hyperinflation, the monthly inflation rate was thousands, millions, 79 billion% over the course of a month, which translates to an annual inflation rate with compounding on that. I don't even know I'm a native English speaker. Right? I grew up with this language. I don't know the name of that number. I don't know it. It's just a huge, that's hyperinflation. Hyperinflation is not, you know, 10% or 20% inflation. That might be high, maybe even 100%. Prices doubling over the course of a year is high inflation. Sure, there's many reasons, and we're going to talk about some of them a little bit in this course, why a lower inflation is good, but that's still not a hyperinflation. But how do we measure this? You can see some of the problems. They start to have like a, you know, the official exchange rate. They didn't change that often enough, right? And this is how we start to get problems. Talk about relative price differences between goods on Friday. Right? If one good is price goes up and another good's price doesn't go up, then that one good becomes less or more expensive relative to the other. Right? And we start to see situations where there's an official exchange rate, but then the market exchange rate is different. So this gives you, you know, what maybe I should buy dollars from the government at the official exchange rate and go to the market if the exchange rate's better that way. You can think of arbitrage opportunities here. Right? So the shape of this should be familiar. The shape is right, maybe a hockey stick. What kind of an increase is this? It goes up like this, exponential increase, right?
Exponential.
But look at the y-axis. It's already log scale. So this means it's the axis is going up exponentially. So the exchange rate was going up exponentially on an exponential scale. So it was double exponential. So, I mean, shooting off to the moon. Hyperinflation. Yeah? We got the same thing in Germany 100 years ago. Currency was not as pretty back then, right? So, March 1920, 1 mark. Yeah? And 1 year later, we have 100 billion, but the Germans count differently. They have, we have 1,000, then 1,000 is a million, 1,000 million is a milliard in German. And if you learn maybe English from British English, the British used to use this historically. They've now switched to the American way, I think they call it. So 1,000 is a million, 1,000 million is a milliard, and 1,000 milliard is a billion. So this 100 billion is actually, 100 Billionen is actually 100 trillion. So this is the same progression, right, that we saw here. Right, so nothing special about Zimbabwe or Germany, right? This hyperinflation, similar patterns. Yeah? Right, and these two weren't even the biggest inflations. In Hungary, in 1946, they had an inflation rate of about 200% on a daily basis. So the price level would double between the beginning of class, right, and the end of class today. Which translates into a monthly, not an annual, but a monthly rate. It's so big we have to express it in scientific notation. Right? So this is, and we can start to go down. Germany's inflation rate was very, very high. Monthly rate, right? Daily inflation rates higher than what we would expect on an annual basis then. So hyperinflation. Right, so long story short, when we're thinking about how much to invest in a nominal security, in this bond today, we're going to be thinking about how much this is going to pay us out in terms of the currency in the future, and how valuable having that currency in the future is going to be. Right? So already here, we haven't started talking about monetary policy directly, but when people are making their investment decisions, monetary policy has a strong incentive to manage people's expectation of where the price level is going to be. Inflation expectations is one of the cornerstones of monetary policy. And managing expectations, right, has two, it sounds like managing expectations sounds like controlling expectations, right, or influencing expectations. Let's just tell people, right, expect the right thing. Communication is important, but you also have to follow through. Right? Remember, we thought of the idea of if you expect 3% inflation, but it turns out to be 6%, this surprise might have some effects that politicians are interested in, but you can't be surprised over and over and over again. Eventually, so there's in English, we have a figure of speech. So figure of speech, you probably learned some. I'm sure there's, every language has them. I think they're beautiful. I learned German, and it's fun when you sing where there's something different. So in America, if you're very hungry, you can say, "I'm so hungry, I could eat a horse." All right? Okay. Sure. I guess where does that come from? We have another sort of saying in America. George W. Bush, our president 20 years ago, was famous for using these figures of speech but getting them all wrong. He made all sorts of mistakes. He made all sorts of mistakes in things that he said. One of the things that he said that for us is important to think about managing expectations. He said, "Fool me once, shame on you. Fool me twice, you'll never fool me twice." Which doesn't make any sense. The way the expression goes is, "Fool me once, shame on you. Fool me twice, shame on me." Right? The idea is it's not nice to fool other people. So if you fool me, then shame be upon you, right? That wasn't nice of you to fool me. But if you can fool me, if you can trick me twice, I'm the one who should be ashamed because I'm not learning. I'm not figuring it out. So one of the important ways that we manage expectations, right, is not thinking we can trick people over and over again or surprise people over and over again. So to maintain low inflation, stable prices, it's not just enough to promise we're going to keep prices stable. The central bank has to follow through and keep their promise. Right? Otherwise, people are going to change their expectations. All right, we're almost coming back here. So from the point of period 0, this looks a little bit problematic. Right? It doesn't line up with what we saw before. We can take this, well, if we go back to the t equals 0 variables. Right, so let's look at the time 0 perspective, but at the time 0 variables as well. then we would get, let's see, C0, N0 minus E0, lambda 0. And we can think about now the importance or not lack thereof of these expectations. So, marginal utility from consumption. Does everybody know the marginal utility of consumption right now? Or just stop for a second. How hungry are you? You know that. You can feel that. Yeah? You don't have to form expectations about that. You know right now. What your hunger is. You know. Right, so I can tell you what the value of the dong is to me. Right, I know that lunch cost me at the canteen 35,000 dong. Right, I'm thinking about utility from consumption from being hungry. Right, so if I want lunch, right, to reduce my hunger, and lunch costs 35,000 dong, right, then if you give me to get 105,000 dong, that's 3 meals, that's 3 lunches, that has this particular value for me that I won't be hungry at lunch or dinner, and then tomorrow as well, right? I can figure this out, I know this right away. And likewise, our equation down here gives us then 0 equals E0 lambda 0 Q0 minus beta so almost the same thing as above, right? I know the price of the bond today, right? I can look it up and see if I can, what a bond would cost me, and I know the value of the dong to me. We just figured that out. But I don't know the value of the dong to me tomorrow. A lot of things could change between today and tomorrow. I could find, right, a 500,000 dong note lying in the ground. Oh, right, win the lottery, right? That could change my valuation of the dong. I might lose my job tonight. Exact other direction. It could happen. Please don't. I'm trying really hard for you, right? It can happen. I don't know what the future will hold. I don't know exactly how I'm going to value one more unit of the currency, one more dong tomorrow. And so when we put these two together, we're going to end up with that equation, right? So we can get our at period 0, we can write down the equation in this form, in this familiar form, in a form like 11, right? For periods in the future, it's a little bit more difficult from the time 0 perspective, because then I have to take into account how these variables are evolving together, right? I don't know how hungry I'm going to be in t periods. It's probably going to be different. You're probably going to be less hungry in 10 years from now than you are today. Probably why you're studying so hard, right, to get a good job, better job, higher paying job to reduce your hunger. Maybe ChatGPT makes huge leaps and bounds, and we don't need economists anymore. Oh, it's not going to happen. We're going to be okay. Trust me, right? But that would change things. There's a lot of uncertainty at any given point in time. Right? Knowing how hungry you're going to be, the value of, right? So that's difficult to know t periods in the future. But today, starting at period 0, we can write the Euler equation in this way. And now, right, to write down our consumption for period 0, we're also thinking about consumption for period 1, which means we're thinking about our consumption for period 2, and this whole connection I was talking about. All right, and now, period 1 comes around. So now it's tomorrow. When we're actually in tomorrow, Right? When we talk again tomorrow, you will know how hungry you are tomorrow. Right? You will know whether you've found 500,000 dong tonight or not. Right? Tomorrow comes, you'll have new information. Right? So then here in period t equals 1, you can think of re-optimizing. Right? You'll change your plans. I wasn't planning, maybe my plan for tomorrow is to only eat lunch and dinner, but I wake up in the morning and I'm very, very hungry. Right? So I'm going to re-optimize it. It's okay. I've been planning on not, but I want to have breakfast tomorrow, so then I'll eat something for breakfast. I can re-optimize. Right? Continuous re-optimizing is going to give you then U of C1 over Q1 P1 equals beta. Tomorrow, depending on how hungry I am, tomorrow depending on how much the bond costs, tomorrow depending on how many dong I can turn into a meal, right, will determine how much I want to save tomorrow, right, because that's going to be the cost to me. And on the other hand, I'm going to think about what that's going to bring me the day after tomorrow, which is simply tomorrow's tomorrow. And now, when we start looking at these two, there should be a pattern arising. If I re-optimize in every period, which I will then have UC T, QT, PT. In every period, the cost to me of buying a bond is going to depend on how hungry I am in that period, how much the bond costs in dong, right, and how valuable the dong is in terms of buying the goods that I need to satisfy my hunger. And the gain from buying a bond is going to be that it's going to pay off in the next period. But it's going to pay off dong in the next period. I don't know exactly what that's going to bring me. 2 years ago when I was here in Vietnam, the exchange rate was 25,000 dong to the euro. Last year was 25,000 dong to the euro. This year it's 30,000 dong to the euro, right? It was constant, then it went up. Next year, it might be 30,000. It might go back down to 25,000. It might go up to 35,000. I don't know. I don't know what this exchange rate of these prices are going to be. And this is the same Euler equation that we got when we optimized using this T plus S perspective on Friday. Yeah? So this is how you can connect these all together. There's a little bit of a subtlety in how these are related, which is why I've spent some time on it. Mathematically, there's nothing complicated here, right? It's just about keeping track of your indices. Yeah? And another reason why it's important that I'm mentioning this is that I frequently on exams see people using the E0 because we wrote in problems we often write the problem from the E0 perspective. But then they put the T's in here and they solve out for something like which you can't do, right? It doesn't make, like, we'd be comparing in some period how hungry I am. So the cost of a bond is going to depend on how hungry I am today, and how hungry I thought I was going to be tomorrow 10 years ago, maybe. That's weird. Yeah? When you start to think through this, this is weird. So just kind of look through these derivations here, just the thought process intuitively, so you don't, because that's always sad. You're like, oh, you have to lose points or something, and you've understood the math otherwise, and you have great explanations, and this is just a, it's something that can be avoided by thinking about when we know what, and how we can re-optimize, and what we do need to re-optimize. Okay. The other addition that we had on Friday was assembling our consumption basket. We're now buying, we value CT, which is our aggregate consumption good, our basket of goods. I use the analogy of a wardrobe. Right? We want to put together a wardrobe of clothing, right? And the wardrobe, right, our basket is composed of individual goods. Well, I said individual colors of clothing. We have a preference for variety in equation 2. We want to have, gray shirts, black shirts, pink shirts, blue shirts, yellow shirts. We want to have all the colors in the rainbow. Yeah? And it's a good analogy because it's a continuous object. Right? How many different colors are there? 10? No. A million? Well, an infinity of colors. But even more, it's not just a countable infinity. It's a measurable infinity. It's a continuous object. It's the spectrum of visible light. Right? That's a lot of colors we can deal with. And the reason why we're going to do this is because it ends up making our lives easier later on. In about 20 minutes, we'll see, because each firm I, the goods that it sells to us, is an infinitesimally small component of our consumption basket. And this infinitesimally small is going to make our lives easier when we aggregate and when we think about the incentives that the firm that makes good I has. Right? It can't affect anything in the aggregate because it's so very, very small. The way to understand this, I think, is to think of the opposite. Right? So I don't know, there's maybe I forgot the word. So kamtam was broken rice.
Yeah.
Right? And there's a place that sells fried rice is also popular. It was what's that called? It was kamdien or something?
Yeah,
Kamdien. Yeah? There's a place that sells kamdien right outside the gate here, right? When it changes its price, if it charges more for kamdien, it's not going to change the price level or the value of the dong. And if it doubles its price, the exchange rate between the dong and the euro is not going to change because of the price of the kamdien outside the gate here. It's that small. Yeah? So here, this water is a good exception. This is owned by a company called Nestle. Yeah? Nestle is a very big company, international company that does lots of goods and also does a lot with water. Yeah? If Nestle doubles the price of water in a country, of its water in a country, it will likely, so if PTI, where I is Nestle water, doubles, it might affect the aggregate price level. Because it is such a big company, there's a big portion of the economy. Nestle understands this, Nestle knows this, just like every company thinks about our relative demand function. But we don't want to consider the situation of a company like Nestle that's thinking about the effect of its individual price I on the price level PT. We're going to make our lives easy, and the math will be easy if we just have the kamdien place outside the gate, where they know that if they change their price, the price level of the entire country is unaffected. They take that as exogenously given. The value of the dong is something that's outside of their influence, which I think is reasonable for most companies, most businesses in the economy. But of course, it's also important to keep in mind, if you think about extensions of this model, it's not true for every company. Right? And what would happen if you had some big companies? You could think, we're going to look at a small open economy situation, and we're going to use a similar technique. So tomorrow, the day after tomorrow, we'll look at a world where we have not just 200 countries, but an infinite number of countries. So every country is so small it doesn't affect the rest of the world. It's going to make our life easier with the math. Also important to think about perhaps the consequences when this doesn't hold. Okay. So we put together this basket. This basket then depends straightforwardly when we think about buying one good versus another. We want to have, ideally, we would have an equal amount of both. And if they both have the same price, indeed we would demand an equal amount of both. But if one is more expensive than the other, we will buy more of the less expensive one than the more expensive one. By how much? Well, it's going to depend on exactly how large this price difference is and on how easily we can substitute the one for the other. Right, we thought about perfect substitutes. I think for most people, these two would be perfect substitutes. Right? Maybe not for everybody. Right? Maybe some people really don't like yellow. They're afraid of yellow. Who knows, right? They might have an individual different elasticity of substitution. Right? If these two things, they have different perhaps elasticity of substitutions depending on what we want to do. If I want to clean the board, right? This is good. This is probably also good. Right? If I'm thirsty, this is good.
No.
Not so good. Yeah? So there's a lot of intuition we have about elasticities of substitution, and we're going to summarize all of the elasticities in an entire economy into one parameter, epsilon. So this is measuring the average elasticity of substitution in the entire economy between all the goods that we put into our consumption basket. Average elasticity of substitution. And I gave an intuitive explanation for why we would think that a higher elasticity of substitution would go along with more competition in an economy. And so we can think again, the infinite elasticity of substitution is infinite competition, perfect competition, and this puts us back in a very neoclassical world. Right? We'll be thinking of some intermediate case where there's some competition. Right? We're going to try to buy the cheaper good, but it's not perfect competition. Right, and the final insight, we then express then our demand function relative to the aggregate. And we can think, because we've got this normalization of 0, 1, the aggregate consumption, think of this also as our average consumption of the different goods. So we will consume, the amount of good I that we will consume would be equal to the average consumption of a good if its price is equal to the average price. We will consume more of good I than the average good if the price of good I is less than the average price of a good. So here think of total consumption in terms of average consumption. All right, and we got then to these first order conditions 10 and 11. We've looked again, reviewing the perspectives on timing. It's just a timing convention. At period t, we'll be re-optimizing every period. Every period we're thinking about consumption today, which depends on our savings today, which depends on our consumption tomorrow, and so on and so forth. So every time today I wake up in the morning, how much I'm going to eat today, I'm thinking about my retirement in 20 years. Right? It's part of the whole package. Right? Of course it is, right? if I wake up tomorrow and I've won the lottery, right, in America, so as an American, I think about America. Every time I go back home, if sometimes there's a big lottery in America. If it's the Powerball jackpot lottery, and when the jackpot on the lottery is high enough, then I think it makes sense to buy a lottery ticket. So it was $1 billion the last time I was there. So imagine, you buy a lottery ticket and you win, and you wake up in the morning and you've made $1 billion, which would be like what, $30 trillion, right?
Amazing.
You know what? I'm not worried about retirement anymore. This has changed all my thoughts about the future. Right? And I'm going to change my consumptions today. But again, every single day, today, I don't know whether I'm going to win the lottery or not. I don't expect to. I think the probability that I'm going to win the lottery is very, very small. So I'm going to be thinking about retirement. I'm not going to spend all of my money today. I'm going to be saving this and that. When tomorrow comes, I'll have new information. I'll know how hungry I am tomorrow. I'll have new information about the future. And I'll change, adjust, adapt my plans accordingly. All right. We can express this in a log linearized form, like 12 and 13. If we assume this particular utility function, if you download the slides this morning or before, you don't have this slide. I added it in, and it's up on the e-learning platforms. It's a new addition. This is just one popular utility function. So how do we value at any period in time our consumption and labor? Right. So this is our concave utility. Right? I drew that. I told you my favorite picture in economics with that. Right. This parameter sigma here measures my constant of relative risk aversion. Right, so you can think of this utility function is designed such that relative risk aversion is a constant, right? And it doesn't depend on C. Otherwise, you can think of risk aversion being dependent on the level of consumption. But this utility function is defined such that this term here, relative risk aversion of consumption and of labor, are constants. Right, and just the subtlety here, 1 minus sigma, and here we have 1 plus phi. We have the minus out in front. That's again here to remember we have N is labor, and C, right, is consumption. So the more consumption, the happier I am. The more I work, the less happy I am. They work a little bit differently. They go in different directions. So that's why we have these plus and minuses a little bit different. Okay. And we can take our utility function, plug it into here, do the derivatives, and then log linearize at 12 and 13. And I think that's going to be a great thing to look at together after we take a 10-minute break. Okay? So I'll see you in 10 minutes.